Hi students, in this video I'll be going through the 2022 O-Level Additional Mathematics, paper 1, question 12. Right, so let's read the question. So the diagram shows a computer screen. There is 120 cm wide. So a dot oscillates in a straight line on the screen between 2 points A and B on the edge of the screen. So over here you have a particular dot. Okay, let's say it starts at O. So it will just oscillate between the points A and B, meaning that it will just go this direction. Okay, once it hits A, then it go back this direction, go past O again, and then continue to move to the right. And then once it reaches B, it then goes backwards and then returns back to O. Right, so this action will just keep on continuing. All right. Okay, so let's continue reading the question. So displacement of the dot from O, the center of AB is modeled by the equation x equals to A sine nt, where t is the time in seconds after passing through O, and A and N are constants, right? The time for one oscillation is 6 seconds, right? So the time it takes for one complete oscillation, meaning let's say it starts at O, it goes to A, from A go back to O, from O go to B, and then from B go back to the starting position O. Okay, so that is considered as one complete oscillation. Okay, so in this case, the time for one complete oscillation, okay, in other words, is 6 seconds. It also means that the period, okay, the period for this particular scenario, right, for this dot moving to A, then back to O, then from O to B, then back to O again, is actually 6 seconds. Okay, it also means that the period for this particular trigo function is also 6 seconds, all right? Okay, so we're going to make use of this info to help to find the value of A. They want us to explain why it's 60 in part A and explain why the value of N is 1/3 pi. Alright, so you recall if let's say you have a trigo function x equals to A sine nt. Okay, do you recall what does this letter A stand for? Right, so this letter A actually stands for, if you have recalled correctly, it actually refers to the amplitude of the graph. Okay, so the amplitude of the graph is actually the maximum displacement of the graph from the center position of from the center position of the graph, right? Right. Okay, so if you recall, if you have a sine graph, okay, which looks like this, right? So this one, the x-axis in this case will be the center position. So the amplitude will be the maximum displacement. All right, so if you look at this case, the dot will start at O, oscillate to A, and then from A go back to O, then from O go to B. Okay, so the maximum displacement will be, okay, from the center position will be from here to here. And you can see very clearly that it's going to be 120 divided by 2, right? Okay, so that will give you the maximum displacement, which is also the amplitude of the graph, right? So let's write that down. So amplitude, so they want us to explain why the amplitude A is 60. So amplitude A equals to maximum displacement, okay, from O. Okay, so in this case, it will be 120. It will either be OA or OB now. Okay, so either OA or OB, okay, which will be 120 divided by 2, which will give you 60. Right, so this is how you obtain the answer. Okay, so the next thing will be they want us to show that N is 1/3 pi, right? Okay, so for this one, we need to do some recap first. Okay, so over here, we know that the period is 6 seconds already. Okay, but do we recall how we can obtain the period if we are given a trigo function? Okay, so let's say if you recall, okay, I'm going to write over here. Let's say the trigo graph is the trigo function is y equals to sine 2 theta. Okay, so you recall this 2 over here means that within a time frame from 0 to 2 pi, right? Okay, there will be 2 complete oscillations. And period is the time for one complete oscillation, right? So if it's two complete oscillation within 2 pi, means the time taken for one complete oscillation will be pi, right? So how do we obtain the pi? So how do you obtain the period pi? Okay, very easy. You always take 2 pi. It's always 2 pi on top. Okay, divided by this number over here, 2. So the period is going to be pi. Right? So let's say the graph is sine equals to half theta. Okay, so the period will be, okay, still the same. 2 pi divided by the number in front of the x or theta. In this case, divide by half, you will get 4 pi, right? Okay, so in this case, the number in front of the t, okay, now it's t, not theta, right? Is n. Okay, so this means that, okay, so let's form an equation. So the period is 6 seconds, okay, given by the equation. Okay, so remember, we always take 2 pi divided by the number in front of the theta x, or in this case, t, right? So in other words, 2 pi divided by n will give us 6. Okay, so this will allow us to calculate n very easy. So n will be 2 pi over 6, which will be 1/3 pi. Okay, so we have shown this already, right? Okay, so this is how you obtain the value of n. Okay, so next part, obtain an expression for the velocity of dot at time t, and hence deduce its maximum speed. Okay, so the equation now, since we have found a and n already, we can actually rewrite it as x equals to, okay, so a is 60, and n is 1/3 pi, right? So 1/3 pi t. Right, so this one is displacement. Okay, so this is displacement. Okay, so now they want us to find velocity. So we know that velocity will be rate of change of displacement, so dx over dt. Okay, so now we will need to differentiate the equation for x, and then we'll be able to obtain the equation for the velocity. Okay, so to differentiate a trigo function is not difficult. Differentiate sine, you will actually get cosine. So 1/3 pi t. Okay, so we need to do one extra thing. We need to differentiate this 1/3 pi t. Okay, if we differentiate, we just get 1/3 pi, then we'll just multiply by 1/3 pi. Okay, so 60 times 1/3 pi. Okay, let's combine these two. 60 times 1/3 pi will give us 20 pi cosine 1/3 pi t. Right, so this is an expression for the velocity already. Okay, next part, they want us to deduce its maximum speed. Right, so this is the equation for velocity, which is 20 pi cosine 1/3 pi t. Okay, so what we want to do is we want to focus on this trigo function. Okay, let me change the color of the pen. Okay, focus on this trigo function. So we know that a trigo function can only exist within this range, right? Okay, greater or equals to -1 and less than or equal to 1. Okay, so meaning in order to obtain the maximum speed, okay, I'm going to take cosine 1/3 pi t to be 1. Okay, so the maximum speed is now going to be 20 pi times 1, which will give us 20 pi. Right? So this is how it works. Okay, so always examine the trigo function and recall that if it's sine or cosine trigo function, it will only exist within the range -1 to 1. So if I want the maximum speed, now I will take the maximum value, okay, for cosine 1/3 pi t, which is 1. So 1 times 20 pi will give me the maximum speed, right? Okay, so let's write that down. Okay, so maximum v equals to 20 pi cm per second. So this is the answer when cosine 1/3 pi t equals to 1. Right? Okay, so this is how we come to the conclusion, okay, of what is the maximum speed, right? Okay, let's look at the last part of the question. Okay, so last part of the question, they want us to find the magnitude of the acceleration of the dot. Okay, let me stop inking first. Okay. Okay, so find the magnitude of the acceleration of the dot when it is at A. So now they want acceleration. Okay, so just now we have already found V, right? So V is 20 pi cosine 1/3 pi t. Okay, so now they want acceleration. If you recall, acceleration is rate of change of velocity. In other words, dv over dt. Right, so now we will need to differentiate this one more time. Okay, so differentiating trigo function not too difficult. So differentiate cosine 1/3 pi t will get negative sine 1/3 pi t. Okay, then same thing, differentiate the 1/3 pi t and you will get 1/3 pi. Right, so we just multiply here. Okay, so in other words, you are going to get over here negative 20 over 3 pi square sine 1/3 pi So this will be the expression for the acceleration of the dot. Okay, but now they want us to find the magnitude of the acceleration dot when the dot is at A, right? Okay. So now we need to know at A, what is the timing over here? T is equals to what? Okay, so if we know the timing, we can just sub the T inside, the time inside T over here. Okay, we place it here, then we can be able to compute what is the acceleration already. Alright, so the dot, let's say the dot starts here. Okay, remember it takes 6 seconds, okay, for one complete oscillation, meaning that to go here, okay, then after that, go back to O, from here, go here, and then once it reach B, go back to the very start position, which is at O, that will be one complete oscillation. So you can see that for one complete oscillation, right, the timing, right, is actually divided into 4 parts. Okay, one part is from O to A, then A back to O, then O to B, then B back to O. Okay, so the 6 seconds divided into 4 parts. Okay, so if I want to go from O to A only, that will take me 6 seconds divided by 4, which is only 1.5 seconds. Okay, so in other words, I can actually substitute okay, T to be 1.5. Okay, because it will take 1.5 seconds to reach A only. Alright. Okay, so what we can do is we will do that. Okay, so at A, T equals to 1.5 seconds. Okay, so acceleration will be negative 20 over 3 pi squared sine 1/3 pi times 1.5, right? You will get negative 20 over 3 pi squared sine. Okay, 1/3 times 1.5, you'll get 0.5 pi. Okay, so 0.5 pi is actually sine pi over 2, which is sine 90. And we know that sine 90 is actually equals to 1, right? Right? So this one will actually be equals to 1. Okay, so the acceleration would be 20 over 3 pi squared. Okay, so over here, if you look at the question, they want the magnitude of the acceleration. Magnitude means they do not want you to include the negative sign in your answer. They just want to know the size of the acceleration. Okay, so we can actually just say that magnitude equals to 20 over 3 pi squared. Okay, so we can actually just drop the negative sign. Okay, so the next question that some of you are asking is, may ask is that, how do you know the particle is going from O to A in the beginning? Why not O to B first, then B to O, then O to A, then A back to O again? Okay, for one complete oscillation. Okay, so we can actually do it that way: O to B, then B to O, then O to A, right? Then A to O. Okay, so if you go through this process, O to B 1.5 seconds, B to O another 1.5 seconds, O to A another 1.5 seconds, meaning to reach A, the timing could also be 4.5 seconds, right? Okay, so we can actually try. What if we start 4.5 seconds? Will we end up with the same answer? So at A equals to at A, right? T equals to 4.5 seconds now. Okay. Okay. So A will be equals to negative 20 over 3 pi sine 1/3 pi 4.5, right? So okay, so over here you will get 3 over 2 pi or 1.5 pi. Okay, so 3 over 2 pi is actually 270. And if you recall, sine 270 will actually give you negative 1. Right, which means that A will now be 20 over 3 pi squared. Okay, so we actually get the same answer. Okay, because since now we're only looking for magnitude, means we want to know the size, we want to disregard the negative sign. So the magnitude will still be the same answer. Okay, so you still arrive at the same answer for magnitude. Okay, regardless of whether you imagine the particle or envision the particle to move from O to A first, then after that move to B, or go from O to B first, then move to A. Okay, you will actually end up with the same answer. Right, so this is how you do a question like this. Right.